Good afternoon. Can you hear me all right?
Yes.
All right. Today I'm introducing the Intelligent Power Wheelchair, or iChair. I'm collaborating on this research with the Advanced Robotics and Automation Lab here at UNR. Unlike the technological shift from the manual wheelchair to the power wheelchair, the development of an intelligent wheelchair is a paradigm shift. Let me begin with a little background first. I had a traumatic spinal cord injury 20 years ago, and I've been paralyzed from my shoulders down ever since. 2 years after my accident, I got an internship at NASA, and I've been modifying my power wheelchair ever since. Next slide, please. By 2007, I had accumulated quite a bit of useful stuff. I had a mini PC that was connected to a pop-up LCD screen, and for the first time, that made my chair into a mobile office. So that greatly increased my productivity. It also included several important safety features, like a rear view camera and lights so that people would never collide with me. I also had some luxury items. I had air conditioning powered by solar panels. And this was called the Griffin Shield Information Technology Upgrade Package for motorized wheelchairs. In 2007, it was awarded a top 25 finish at the Modern Marvels Invent Now Challenge. I was, of course, hoping for a top 3 finish, but there were some legitimate concerns. It was too big and bulky. It only served a small subpopulation of wheelchair users, and it required that the underlying power chair be heavily modified. Next slide, please. Okay. So these days, all of the same technology is a lot smaller. It's a lot more efficient and more powerful. So as you can see, the same Griffin Shield component can now be mounted onto any power wheelchair, and it can be used by any person with any type of disability. Next slide, please. So here we get to take a closer look at what's on my chair now. And it gives me the following capabilities. So I can access the internet, which is always important. I can sketch 3D models of my prototype components that will eventually get printed with a 3D printer. I can write and implement my own computer code. I can prepare presentations like this one. And I can write scientific articles for peer review. And this iChair also has a voice synthesizer. My role model, Professor Stephen Hawking, had to have a voice synthesizer for a very long time, and it really was just a single function device. But now it can be just included, and it'll sound something like this.
Hello, I am Jesse's iChair. I can receive input from a single switch, a touch surface, voice recognition, head motion tracking, and thought control. I can make high-precision scientific observations with an HD camera and 3D scanner. I have 10 high-efficiency LEDs that can emit photons in 7 colors, 10 patterns, and 5 speeds.
Next slide, please. So with these different color options, I can do a lot of cool stuff. I'm going to reserve the teal lights for my long-distance communication. Pink lights are for special occasions like Breast Cancer Awareness Month. Yellow can be used as a turn signal. The white lights are just like a flashlight or headlights. Blue lights I'm going to use just for emergency situations. I'll talk a little bit more about that in a second. And the green lights I'll use for when I'm capturing HD video. Next slide, please. Okay, so up until now, I've been talking about what my system can do today. In the future, thanks to the positioning of the sensors, the HD camera, and the 3D scanner, we can now use that data to give the power wheelchair the intelligence. So light communication, emergency signaling, and collision avoidance will all be standard. And then there's optional upgrades to get object detection, guide following, docking with furniture and vehicles, 3D mapping, path planning, event anticipation, and autonomous navigation. Those will all be optional upgrades, and you will have to have access to our cloud server to be able to use them. Okay, next slide, please. Okay, so the emergency signaling algorithm uses real-time data from the accelerometer to check whether the iChair is still upright. And if it ever tips over or falls back, which has happened to me before, the lights will flash blue and will play an alarm, something like this. That should be annoying enough. People should come to my rescue. And then if nobody's around nearby within earshot, an emergency, a text message will be sent to the contact lists and local first responders. Okay, next slide, please. Okay, collision avoidance. Give me a second here. Because I'm going to show the camera what it looks like for me on my screen. But I have to turn around so that the camera can get it over my shoulders. Can you see it all right? So what the camera sees right now is the TEDx sign. And it works perfectly in the dark. But it also works really well to show my, that you can distinguish features very nicely. And in this particular image, the iChair moves from 8 feet to 2 feet. And you can see that the color changes. So imagine we use that color and instead you have sound. So the closer you get to an object, the louder the sound gets and the more frequent it gets. So this should help anybody avoid collisions. Okay, next slide, please. So after only a few seconds of collecting the 3D point cloud and a little bit of processing, which currently takes about 10 seconds, you can clearly distinguish some of the key features in the room, like the ceiling, the walls, and the refrigerator from the previous slide. Unfortunately, current algorithms can't do this in real time, and they can only do it for one room at a time. So that's going to be something we're going to have to work on. Next slide, please. So once you have object identification figured out, the iChair can lock in on a person or another wheelchair and then set up a following formation. You can follow in a straight line or any other formation you like. Also shown in this picture is the collision avoidance zone. That's the red circle. And the blue rectangle is the iChair's footprint. So anytime the chair needs to go through a narrow doorway, for example, you have to decrease the collision avoidance zone all the way down to the footprint. Okay, next slide, please. So once you can comfortably identify these different objects, you can place them into a 3D map. So let's look at T1. That's the start of the mapping procedure. And you set up an empty iChair-centered map, and then any objects are placed with respect to the iChair. And then you use the coordinates of the iChair to figure out where the object is in your real 3D map. And then you go to T2, the second time of observation, and you moved over by delta x and delta y. You might have changed your orientation from S1 to S2, and then you take you make your observations again, and again you start with an iChair-centered map. And then knowing the transition and the change in direction, you can calculate the new object's position in the real 3D map. Okay? Next slide, please. So one of the best things about building up the 3D map is that you can start planning complex trajectories, either inside of a building or from one part of town to another. In this particular diagram, this is the ARF, stands for the Advanced Research Facility. It's a building here on campus. And ARA is the Advanced Robotics and Automation Lab. So there are 6 steps that I have to go through to get from the entrance, which is a ramp, goes through some electric doors. And then you have to follow the hallway down to 3, make a turn, and then dock with the elevator at 4. Go downstairs, take the hallway again, and then go through the door at 6. So by the time I have my algorithm all worked out, it should be able to do that with one press of a button. So just arriving at the entrance and then clicking on ARA, and it should take me there. Next slide. By the way, I also have water included in my system here, which is really convenient. So I'm currently doing the first phase of human trials. And safety is paramount. And so we've come up with this wheelchair skills test that every trial participant will have to pass. So at 1, you learn, or you have to show that you can turn your chair on and off. And then you go forward to 2. It's like 10 feet forward. And then reverse back to 3. And then show you can make a left turn at 4. At 5, you go up a 5-degree incline. And if you're confident enough to go up a 10-degree incline, you go to 7. And then 8 is just any old rough surface, like carpet or grass. And then at 9, there's a dip you have to get over. And at 10, there's a little raised ramp you have to get over. And then you have to be able to make it down a 10-degree incline and down a 5-degree incline. And then you should have proven that you can handle your power chair and you're safe to go out. Okay, next slide. So phase 2 will be on the UNR campus, and it's going to be a combination of able-bodied students in our department and some local power wheelchair users. And like I said, everybody's going to have to pass the wheelchair skills test before they can go out. And the course will take us from the ARA, my lab, out to the student union, and then down over here to the Knowledge Center where we are today, and then back up to my lab. Okay, next slide. So there's a couple unique job opportunities that have emerged since we've developed this technology. So one is a 3D mapper. So you can go around and collect point cloud data at tourist attractions and public buildings and mass transit systems. And you can use this point cloud data to do city planning, make sure everything is nice and accessible. You can solve crimes after the fact, and you can use it to do counterterrorism, or you can use it in virtual reality games. So there is a demand for these, for this 3D point cloud data. Next slide, please. Okay, another opportunity is for security monitors. With this technology and clearance, you could set up facial recognition, gesture recognition. You can have access to wanted lists, and you can even communicate real time with local authorities. I imagine these security monitors could deter and report illegal activity in malls and universities and other public places. Okay, next slide, please. Okay. Now, this is something that I'm already doing. This is one of the reasons I developed this technology in the first place, because I wanted to document barriers in society that sometimes impede and in some cases even prevent people with disabilities from participating. Reporters have to go to the entrance, check out the seating, check out the availability of bathrooms. If you're in a theater, the view is important, whether or not there's access to goods and customer service. And then they will assign a rating from 0 to 5. Next slide, please. So 0 would be totally illegal. 1 is barely legal, like, for example, a restaurant with a single step and they have a ramp on standby, you know. They're just barely legal, but it's really inconvenient. And then something like the shopping door entrance, where you just roll up to it and it opens up, that's what I would consider universal access. Okay, we got a couple minutes to go. Next slide, please. So for the future, I envision working together with Apple and Tesla to create personal electric vehicles that will have broad appeal beyond just power wheelchair and scooter users. I believe we can attract people who had previously settled for manual wheelchairs, or pushed through the pain of using walkers, or may have limited their daily living activities because of extreme fatigue or pain in the knees. I think we can come up with a solution that may be about $6,000. And I think that by leasing them, we can make it much easier for everyday people to get a hold of this technology. And in any case, if you have Medicare, the 8-year plan should be covered, and you'd only be responsible for something like the cost of a data plan to afford this technology. Okay, thank you very much. Can we go to the next slide? Next slide. One more slide. Yeah, let's not forget who to thank in particular. Davidson Academy, thanks for having me. My engineering team at the Advanced Robotics and Automation Lab. Luan, are you here? Yeah, hey, Luan. Thank you. And my vocational rehabilitation. This is an agency that helps people with disabilities get back into employment. So they were vital in this effort, and I can't forget my caregivers and my family, and especially my dad. I couldn't have done it without you. All right, thanks. I'm done now.